All right, so I just wanted to quickly show you how to do the isotopes and average atomic mass. It is a TEK. I know that you will have a question on it. Well, probably more than one on the test and on your 6 weeks test. So it tells you how to do it here. Just being that you're not in class, I wanted to make sure that you had something else to go back on if you didn't understand what this was telling you to do. So elements come in a variety of isotopes, meaning they are made up of atoms with the same number of protons but different number of neutrons. So all an isotope is it's this exact same element because they have the same number of protons, and protons are what makes an element an element. So they are the same element, but they have a different number of neutrons in their nucleus. Neutrons have no charge. So basically all they do is add mass. So these different elements have the same number of protons, so are the same element, but they have different number of neutrons, so they have a different mass, okay? Now, these atoms with their different mass numbers, we want to be able to calculate their atomic mass, the atomic mass that you find on the periodic table. The atomic mass on the periodic table is a weighted average of all the isotopes on the planet, so like basically in their correct abundance. They must be determined by doing this little calculation. This is the same way that if you wanted to calculate like your grades, like you wanted to figure out what grade you'd be making based on your daily grades, your test grades, your 6 weeks test grades. So like your daily grades are worth 60% of your grade. Your test grades are worth 30%, and your 6 weeks test grade is worth 10%. So basically, if I was trying to find your grade, I would take the average of your daily grades. So let's say it was at 80. Your daily grades, you're averaging at 80. And I would take an 80 and I'd multiply it by 0.6 because that's 60%. Because remember, 60%, if I move the decimal back, is 0.6. All right. So if I took 80 times 0.6, that'd be the percentage that daily grade amount would be taking up in your actual full grade. And then I would take your test grade. So let's say your average test grade was a 52. Like maybe you're doing worse on tests. So you take a 52 times 0.3 because it's 30%, 0.3, 30%. So 52 times 0.3, and then you'd add it to what we just did, the 80 times 0.6, because 80% was your daily grades. And you do the same thing with your 6 weeks grade. So I was just trying to give you like a real life example. Anytime we want to find a weighted percentage, you would use this method. So if I'm given an element, so we have this example here, it says a sample of cesium has these masses. So if you remember our nuclear isotope symbols, if you don't, our test is next week, so let's learn it now. They'll give you the symbol right here. So CS, 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 that stands for cesium. And the top number always means mass, which is protons plus neutrons. On the bottom, usually they write protons, but sometimes they leave it off when it's not important in the circumstance. So like in this case, all we needed was the mass number. So they left off the proton number, but the proton atomic number would be on the bottom in a full nuclear symbol. But mass is always at the top. So they're giving you the mass of these cesiums. And as you can see, they're different. This one's 133, this one's 132, this one is 134. And the only thing that is changing in them is their number of neutrons, making them heavier. But 75% of the cesium on the planet weighs 133 AMU. 20% of the cesium on the planet weighs 132, so a little less AMU. And only 5% of the cesium is 134, being the heavy version, okay? So if I want to find the average atomic mass, which is how we find the mass that's found on the periodic table for every element, this is how they found it, is with this calculation. So I take the percent and I turn it into a decimal, which is always just the decimals at the end, and you hop back to 1, 2, okay? So I end up with 0.75 times the mass, 133, and I get a number. Then I take the next one. So I have 20%, so I'm going to hop the decimal back to 1, 2, and I get 0.2 times 132, because that was the mass, get a number. Put in the calculator. And then lastly, I had 5, so I'm going to hop the decimal back to 1, hop another 1, so that puts a 0.0 in front of it. So 0.05 times 134, get a number. Then add all those numbers up, and that is your average atomic mass for cesium, okay? Now, you only have a couple of those problems to do, but as you are doing them, you do have to show work, okay? If you do not show work, I'm going to count at least half off, because you could just be getting the answer from literally anywhere. And when you get it wrong, which happens often, especially for virtual kids, if you're not showing for Google Meets, maybe you don't know what you're doing. If you're missing it, I need to see what your work is so I can tell you. So I can send you an email and say, hey, I know what you're missing. You're missing this little step here, and that's why you're getting the answer wrong. If I can't see your work, I don't know what you're doing wrong. Okay. Now, if I scroll down, this is review. I just figured I'd review it since I already have you in this video. So you have the element here, the symbol, you just find on the periodic table. So find sodium, or when you find cadmium on the periodic table, it's CD. The group number is always the up and down. So let's Google a periodic table real fast, just so I have it. Periodic table, I want it to be labeled. I'm going to say it's always a good one, is the star periodic table. This is the one that I give you. So I did post this yesterday for y'all to use, but this is always the periodic table I pull up. It just has everything that I need it to have. Okay, so I'm going to find cadmium, which is CD. And I know that, and I know it should be in here. Am I covering up? There it is. Okay, so CD. So if it says the group, it's the up and down. Group is always up and down. It also sometimes is called a family. So it's in group 12 or 2B, okay? So those two different, they're both valid, 12 or 2B. So if I go back, where's the assignment at? There we are. So 12 and 2B, that's how they got it. The period is always the row, side to side. So when I look at the periodic table, I look at cadmium, you go off to the side, and it's number 5. Okay, so that's how you find its period. It's the row that it's in. Is it a metal, non-metal, or metalloid? Hopefully you're understanding that. I mean, that is stuff we learned, in several grades. But remember, metals are on this side of the stair step. Metalloids are on the stair step, and non-metals are over here. Okay, so cadmium is in the metal section, so it's a metal. Not only is in the metal section, it's in the middle, which is the transition metal section. And that was in our last set of notes that we had to label, and you were supposed to label your periodic table yesterday, so you would have it to look at. So cadmium falls in that transition metal section family. Okay, so that's how you do that one. And then down here, it says nuclide symbol and nuclide name. So a nuclide symbol is, let's just Google one. A nuclide symbol. Come on, internet. Give me a nuclide symbol. Here we go. So it always has the element symbol there, the mass number on top, which is protons plus neutrons, and the atomic number, which is the number you find on the top of the periodic table, on the bottom. Okay, so if I was looking at that first example, chlorine, well, the symbol for chlorine is Cl. So this right here would be a big Cl. And then I need the mass number on top, which is protons plus neutrons. They gave me the neutrons, 18. Well, how do I find the protons? Well, protons is always atomic number. So I would look at my periodic table. I'd look for chlorine as 17 protons. So I'd take my 17 protons and I'd add it to my 18 neutrons, and that would be my mass number. That mass number would go on top. So mass numbers would be that 17 plus the 18. The atomic number is the 17 that I found on the periodic table. So it's just 17 right here. And this would be Cl. So that's the atomic number. The nuclear symbol that you're writing. For the nuclear name, so a nuclide name, you literally just write the name of the element. So it'd be chlorine dash mass, the mass number, which you just had to find, which was 18 neutrons plus the 17 protons. So you would add those two things up, and it'd be chlorine dash that number. Okay. And then lastly, we have this very last question is how many protons and neutrons do the following have? So strontium 87. So again, this is the nuclide name that we just did. It's element dash mass. This is the mass number for strontium, okay? So how do I find the protons for strontium? Well, I go look at the periodic table. So strontium is number 38. So it has 38 protons. That's how it works. It's the atomic number, okay? So that's how you know. Now, how do I find its neutrons? Well, if this is mass, which is protons plus neutrons, I know it's protons from just looking at the periodic table, which is 38, okay? So 38 plus the unknown neutron equals 87. 38 plus unknown neutron is 87. So really, if I just subtract the protons off the mass, I get the neutrons. So if I take the 30, it was 37, right? No, 38. If I take the 38 that was on the top of the periodic table and I subtract it off from 87, the remaining is the neutrons. Okay? So I hope that review was helpful for you to do this sheet.